colored pens up. So, what's the probability in number 1 that your identification number would be 7654321? Start with Paige, Isabella, Joelle. Okay. You two agree? So we got 3 people who agree. The correct answer is 1 out of 8,100,000. Number 2. What'd you get? Yadesh, Valerie, and then Caesar. What'd you get, Yadesh? Okay. Okay. Okay, so we have a big disagreement. Someone's getting fired. Who will it be? Michaela and then Yvonne. Negative. So now we're starting to get more support for the answer of -8. Correct answer is -8. Number 3. What'd you get? Ezekiel, Alex, and then Kiana. Okay. Okay, disagree again. Okay, so a couple people think it's -120. What did you think, Gary?
Z equals -120.
So the correct answer is -120. And what about number 4? How many people are sponsoring these 3 individuals? So this time we'll start with Joali, then back to Isabella, and then Sebastian. Okay. So you agree with Joali. What did you think, Sebastian? Okay, so we're in agreement that Fred has 18, Mila has 19, Jackson has 21. So, let's go back to number 1. I want to focus on one question at a time. Give me a thumbs up if you got number 1 correct. Wow. A lot of people got that correct. Wow, that's amazing. Put your thumbs down. It's a really hard question. You got a lot of confidence too. How come so many people seem to get it right? What's with all the confidence all of a sudden? Brianna? Okay. I agree. I think there was a tremendous difference between last lesson and this one because we had a question just like it. A question just like it. Okay? So what was the detail that you had to really be aware of to make sure you got the right answer? Chris? First digit and the last digit could not be 0. And so that impacted the number of choices for the first position and the last position. So you still should have done something like this. There were 7 digits, but how many choices are there for the first position now? Because of the detail that Chris pointed out. Kiana? There's only 9 choices. Because 0 is no longer one of the choices, so we only have 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 choices. Which means the last digit only has 9 choices, and all the digits in between can be 0, so those positions have 10 choices. And when you multiply all those together, that's how you get the 8,100,000 different possible ID numbers. And then I said, what's the probability that if we randomly create one, that it will come out to exactly 7654321? So how many ways are there to get this combination? There's only one way. So this right here, remember, just tells you the denominator, and then you have to think about the numerator. Comments, questions on number 1? And I was very impressed with my students, so keep up the good work. All right, comments, questions on anything else? That's the one I wanted to go over. Anything else? Caesar and then today. Number 2 today?
No, it's first class.
Okay. Hold on a moment. So number 2, there seemed to be a lot of people who got different answers, although we did end up with quite a few who had -8. And so, what's the first step in solving this equation? What's the first step? Michaela? What are the like terms? Very well stated. And when we combine those, Michaela, what do we get? Good. So this turns into this equation. 10x minus 2 equals -82. How many steps do we have left at this point? Selena? 2. It's a 2-step equation. What's the next step? What's the next one, Gary?
Add 2 to both sides.
You said that perfectly. Add 2 to both sides and watch what we get. This cancels, so we're left with 10x equals, and now a -82 and a +2. What does that come out to, Isabella? -80. So 10x equals -80. What number must go there? It must be a -8. So some of you went wrong because you ignored the negative sign, or when you added 2 to both sides, you didn't add correctly. Caesar, what was your mistake?
Well, I think I did keep, change.
Mm-hmm.
And then I combined it.
Well, that's fine. Keep, change. That's a -13x and a 23x. It still comes out to 10x.
I have 36x minus
Okay, so unfortunately you did keep, change, keep, which doesn't exist. You kind of made up your own rule. Fortunately, your rule doesn't exist. Okay? Comments, questions, concerns on that or anything? Page. Number 4. Okay. So let's take a look at number 4. And number 4 last time is all about defining what is going on. We've got 3 characters in the story, and we're asked something about each of them. So we need to define each of them. So we need to make a list of the definitions for each person. So what is the definition of Fred? What's the definition? Gloria? Yeah, it tells you that Fred has P people sponsoring him. That's his definition. But now the rest is reading. Remember, I've told you that the math test is a reading test. So now we have to define Mila. And so what will Mila's definition be? Valerie? P plus 1, and we get that by translating this statement. Mila has 1 more than Fred. Here's Fred's definition. Add 1 more to it, and you get P plus 1. So Mila's definition is based on Fred. Now Jackson. What's Jackson's definition going to be? Udesh? P plus 2. So let's see if that will work. It says Jackson has 2 more than Mila. So now I have to look at Mila and add 2 to that. So here's what it really is. That's Mila. And now I have to add 2 to that. So what is Jackson's definition really? Jed Lee? It's P plus 3. And that's how I got this right there. So today's question was significantly different than last time's. Okay? But it was the exact same structure, the exact same style. All I did was change names, numbers, and a few of the details. Okay? Setting this up is a key to being successful because you're setting up the definitions for each person and then you can work through what you have to do with them. It says that they have a total of 58. What's the first thing since probably the first week of school that I've been telling you to try and find and write down when you're trying to solve something? What's the first thing I tell you to find and write down? Briante? A total. If possible, find a total and write it down all the way on the right. And then that helps you focus your attention on, well, what has to arrive at that total? Well, Fred, Mila, and Jackson have to arrive at that total. Fred, Mila, and Jackson arriving at that total by adding them together. Paige, is it starting to become clearer now? Sure? Okay. Other comments, questions, concerns? Side note, yes, this is lesson 7.1, and yes, lesson 7.1 comes after 7.2. That is the way I wanted to do it. It's not that big a deal. Just make sure you've labeled your lesson correctly. Put the warm-up to the side. Today, we're going to explore a concept formally, even though informally you've been doing it the entire year. I just got your grades from you, and the grades that we produce based on these yellow slips that I gave you are always partially based on a percent. So you guys have actually been finding percents since the first week of school. I do this partially by design. You should, at this point, feel like finding a percent from a fraction is just a joke. I mean, it should be effortless for you. You shouldn't have to think about it at all. But we are missing a few connections between the concepts. So that's one thing that I want to establish today. So fractions, decimals, and percents. 3 different ways at looking at the exact same piece of information. And I've used this analogy before, but I've used the analogy of money. So let's just review that really quickly. Can someone give me one way to construct a dollar using some form of money? Ezekiel? 4 quarters is one way to make the value of a dollar. And I use that word intentionally, value. 4 quarters is the value of a dollar. Give me another way to make the value of a dollar. Alex? 20 nickels will also give me the same value. But picture it in your mind. One's 4 coins and one's 20 coins. 4 coins has a value of a dollar. 20 coins has a value of a dollar. Michael, give me another way. 10 dimes is a value. Give me another way. 2 quarters and 5 dimes. So that's 7 coins. His is 10 coins. His was 20 coins. And whoever the first person was 4 coins. So we have all these different numbers of coins, but they all have the same value. Got another way, Gently?
1 quarter, 1 nickel, 9.
You've already surpassed yourself. But that was a good effort. Okay. Will you say fail? You have another way, Gloria?
1 quarter, 2 dimes, and nickel, 8.
Okay, sounds about right. So again, you guys, you're doing a good job being creative. That's what I like. But the lesson is not about how to make a dollar. The lesson is try to. The point is that all of these ways look completely different, but they all have the same value. And that's the idea between fractions, decimals, and percents. Different ways of looking at the same value. So for example, you already know how to convert between fraction, decimal, percent. You do this every day in my class. 1/4. How do we get from 1/4? How do we get from here to here? It can be said in 4 words. Yadesh? Okay, so someone say it in a generic way. How do I always convert a fraction to a decimal? Joelle? Top divided by bottom. That's what I've been saying to you from the beginning of the year. Top divided by bottom. How do I get from the decimal to the percent? How do I get from the decimal to the percent? Well, everybody's hand should be up because you do it every day in my class. So you either are just being shy at the moment or you rely on someone else to do it for you, which is not okay. Valerie? Yeah. So Dr. Pepper is a method that Ms. Cooper taught you if you were fortunate enough to have Ms. Cooper. This is a great memory device. The D stands for decimal and the P stands for percent. So this method actually helps with a number of different things. If you want to go in this direction from decimal to percent, that means you go from the D to the P, and the decimal will go over here. If you want to go from percent to decimal, if you wanted to go in the opposite direction, then you go from the P to the D, which tells you you take the decimal and you move it that direction. So you now know how to go from here to here. So you actually know a lot more than you realize. Okay? Any comments so far? So, slightly less common. So now we've got 60%. How do I go from the 60% and get 3/5 from it? This is probably the one piece that you know but don't realize that you know and maybe don't know how to verbalize. Yvonne?
Well, you have to put 60 over 100 to simplify.
That's exactly right. What is really happening is you are taking the 60 and you are taking the percent symbol and writing it like this. Then you have to put it in simplest form. What are the top and the bottom both divisible by? What are the top and the bottom in this case both divisible by? Chris? They're both divisible by 20. So if you divide the top by 20, divide the bottom by 20, then you get the 3/5. So you actually know how to go from fraction to decimal, decimal to percent, percent to decimal, percent to fraction, and then I don't have to do this other one with you because you already know how to go fraction to decimal because we just did that over here. And that's what Joali said, top divided by bottom, you get to 0.6. So you actually already possess the ability to convert between all three forms of the number in any order, in any direction. Okay? Deadly. Okay, so, does anyone have any questions about this? Now, there are shortcuts to many of this, and maybe you knew some of it, maybe you didn't. But today's goal is to really take your understanding of converting these numbers and bring it to a much higher level. Because when you get to algebra next year, you cannot spend any time trying to figure out what the equivalent number would be for something. You can't spend any time with that. You have to be able to focus on the algebra part, which is really, really challenging. So all of this has to be effortless. So let's talk about this concept, friendly denominators. how can we use friendly denominators when working with fractions, decimals, and percents? I'm going to try to use my spotlight, see if this works. So, I've actually already put up, but don't do them all at once. We're just going to do one at a time. But I've got all the friendly denominators when you're talking about percents. And it is all based on the concept that Kevon illustrated, which is that a percent means out of 100. Out of 100. So if I can get a fraction to turn into something over 100, then the number on top is the percent. So for example, I'm going to start with a simple one. 3/4. You already know that you could do top divided by bottom and then Dr. Pepper it to get 75%. But here's a shortcut that you can use. And it's just like the shortcut with proportions that you learned. What is the factor down here that is being multiplied by 4 to get the 100? Chedley? Times 25. So if I multiply the top times 25, then I will get the number that goes right here. 3 times 25 is 75. 75 out of 100 is 75%. So yes, if I truly had to, I could take out my calculator and go 3 divided by 4, 0.75, and then as Valerie described, Dr. Pepper it 1, 2. But now I have a shortcut at my disposal. Mental math. The top is being multiplied by 25. The bottom is being multiplied by 25. Multiply the top times 25. Comments, questions?
Does that shortcut work with every
You're going to see some others, and then you ask your question at the end, okay? Okay, so let's look at another one and see if we can answer Selena's question. What if the denominator is 5? That is also what I am calling a friendly denominator. What makes it friendly is that 5 is a factor of 100. So what factor would we have to multiply by 5 to get the 100? Selena? 20. So if I multiply the bottom by 20, then whatever is on the top will also get multiplied times 20. So, someone pick a numerator for us. What fraction will we have? What out of 5? Ezekiel? 4. So if I have 4/5, what will that be as a percent? What percent is that? Yadesh? That's 80%, because I know that if the denominator is 5, I multiply times 20, multiply the top times 20, and I get an 80 out of 100, which is 80%. So, what do you think so far? Okay, it's just a different number that you have to multiply by. So here, we had to multiply by 25 because the denominator was 4. Here we multiplied by 20. Let's look at another one. If I had to guess, over your academic career, you've probably taken a lot of quizzes in your lifetime that had 10 questions. Yeah? Give me a thumbs up if you agree with that statement. You've taken a lot of quizzes that have 10 questions. Put your thumbs down. Any idea why? It should be coming clear to you at the moment. Why? Mikhail? Yeah, it makes it super easy to grade because I am super smart. And I know that I can multiply this times what? Times what, Danae? Times 10. So no matter how many questions you get right, I can quickly calculate your percent doing mental math. If you get 7 out of 10, I know that that is a 70%. Stop doing that. A 70%. Once I get it out of 100, I know that that's the same thing as a percent. Now you know why so many teachers give quizzes out of questions. Comments, questions, concerns so far? All right, so let's round it out with the other friendly denominators. If the denominator is 20, that also makes it super easy to calculate a percent. What would I have to multiply the numerator by to turn a fraction out of 20 into a percent? Chanel? Times 5. Because this is times 5, multiply the top times 5. So however many you get correct, multiply times 5, and you get the percent. Now I'm using mental math, which is much more powerful and much more accurate than a calculator. You've probably, maybe not as common as the 10-question quiz, but you've probably taken some tests and stuff with 25 questions. Not 24 and not 26, but exactly 25. That's done on purpose, so that it is super easy to grade. Someone pick a number of questions that we get right out of 25. Someone just make it up off the top of their head. Brianna? 21. Great. Perfect. 21. So what percent is that? Can anyone do that super fast right now without having to use a calculator or do anything? Yvonne? 84. How'd you do that so fast? Oh, I love the way you broke that down because that's exactly what I would do as well. But we know that it's times 4, and he took it a step further and he said, well, I don't know what 21 times 4 is, but I can do 20 times 4 and I can do 1 times 4 and add it together. And that becomes 84. And then the easiest of them all, if the denominator is 50, what do you have to do with the numerator to get the percent? Isabella? Yeah, just double it. Multiply it by 2. So if you've got 30 out of 50, that's a 60%. So now, when you do my yellow slips in my class, unfortunately my homework assignments don't often come out perfect friendly numbers, but sometimes they do. And if they do, you should easily be able to find the percent without using a calculator at all. In fact, you should be very conscious of if you can do it without a calculator. Okay? Don't ask, just go do it. Okay, any comments, questions on friendly denominators? Oops, excuse me. Comments, questions? Good. Draw a line across your paper. Let's see how well you can employ it. You got your classwork. Page 347. You are going to do 9 through 23, the odd questions. And then number 29, 31, and 33. Make sure you do the odd numbered questions. That's 9, 11, 13, 15, 17, 19, 21, and 23. But remember, there's going to be a lot of mental math going on, a lot of quick math. This is a very skill-based lesson, not really a huge amount of thought. The idea is to become incredibly efficient at this.
That's what I'm saying. I can do it. This is
No, it's not. I know.
Okay, colored pens up, and let's see how well we understood this short but important lesson. So, first four probably took you the longest, just because you had to put it in simplest form, each one in simplest form. Number 9 is 2/5, number 11 is 27/100, 13 is 9/50, and 15 is 17/20. The next four should have taken you a nanosecond each. Based on the lesson today, you should have easily been able to figure out what each one of those was.
She got 17.
And now the probabilities, so now we're combining an idea from the last chapter and reinforcing it with what we just learned. The probability of randomly getting the number 4 is 1 out of 10, which is 10%. An even number, 50% chance, because 2, 4, 6, 8, and 10, that's 5 out of 10. Prime numbers. How many prime numbers are there between 1 and 10? There are 4 of them. 1 is not a prime number. 1 is not a prime number, although lots of people think it is. There's lots of adults who think it is. 1 is not a prime number because there's only one number that you can multiply to get 1. That's 1 times 1. So the prime numbers are 2, 3, 5, and 7. 2, 3, 5, and 7 are the prime numbers between 1 and 10. So, all right. Draw a line across your paper. Your homework is page 347. Numbers 8 through 44 even, and 64 to 70 even. That comes out to 23 questions, but you've seen that quite a few of them are very easy and require quick mental math only. And you will have a quiz next week. I have to work out exactly which day, and I will let you know tomorrow.